Hey everyone, in this video we're going to talk about section 3.5c, which is about area of triangles. This is going to wrap up unit 3 by giving us some additional tools to be able to find unknowns within triangles. So, back in your geometry days, you learned how to find the area of a triangle using 1/2 base times height. Okay, so now that we know trig, we better know how to solve for the height or the altitude of the triangle. Okay, so your trig identity sheet is going to give you 4 different formulas. One of them you should already know, but let's talk about where the other 3 come from, okay? I'm gonna do this on that extra space page. You can do it wherever. Okay, so let's say, for instance, that we have a triangle, okay? And let's say that it's a side angle side triangle. So, like, what I mean by that is I have this angle and I have these two numbers around it. Okay, so let's say, for instance, this is A, this is B, and this is C. So I would be given what angle A is, I'd be given what lowercase b is, and I'd be given lowercase c. Okay, so I know that if a triangle's formula is 1/2 base times height, well, great, the way that I've drawn my triangle, I have what my base is. Okay, my base is equal to B. Okay, what we don't know, though, is we don't know what the height is. Okay, we know that the height of a triangle is its altitude, and an altitude is always going to connect the top of the triangle to the bottom with a perpendicular line. So it forms a 90-degree angle. So now, so when it does that, we get 2 right triangles out of it. And this is good news for us because we know right triangle trigonometry to solve for unknown sides within right triangles. So we can let this side length be h, and we can go ahead and we can solve for what h would be. We can solve for that altitude. Okay, so if I set up a trig statement for this, okay, I have my theta, this side would be my opposite, and then I do have the hypotenuse across from 90. Okay, so I could say that sine of theta is equal to h, my opposite, over c, my hypotenuse. Okay, and if I go ahead and if I solve for h, well, I need to multiply c to the other side. So h is equal to c times sine of theta. Well, in this case, b was my base, okay, and we just solved for h. So the area of our triangle can be written as 1/2 b times c times sine of, and in this case, our theta was equal to a. So that shows us what let's see, this formula is. Now, one thing I recognize with how these formulas are written is the uppercase A is being used to represent 2 different things. So these 3 A's here are representing your area, and this A right here is angle A. Okay, so these formulas are good in like kind of reminding you like what this looks like, but just be aware that that A on your formula sheet like does mean 2 different things depending on its placement. So this formula works for the different types of triangles you have. So really, the 3 different formulas are kind of are nice, but honestly, I feel like you don't really need them. You just have to be able to set this up depending on what you have and then be able to solve. So like for instance, let's say that our triangle, I don't know, maybe instead of having angle A, I had angle B. Great, I'm going to put angle B here. Maybe A is here and C is here. And that's still going to let me, solve for it. So what I'm trying to say is these formulas are helpful, but honestly, I think that it's worth your time to just draw the picture out and then calculate what your area is. Or if you can recognize all the information you have, you can pick whatever formula you need to and plug it in. But regardless, you should be able to do this without looking at your formula sheet because you know how to derive it. So this is what we're going to look at in example 1. So it tells us we're going to find the area of the triangle given that angle A is 64, side length B is 17, and side length C is 9. So I know I could just plug that into my formula, but let's draw it out so we know why we're getting what we're getting. I know, I'm making you think. Okay, so we know that angle A is 64. We know side length B is 17 and side length C is 9. So again, we know that the base is 17. If we need to find that height, I know that I could say that sine of 64 is equal to the height, over 9. So the height is equal to 9 times sine of 64. So if this is our base, this is our height, my area should be equal to 1/2 times 17, my base, times my height, which is 9 times sine of 64. And now we're good to go to plug in into our calculator. And again, we should be in degree mode because our angles are given in degrees. So when you go ahead and do so, hopefully you're checking my answers. Our area should be equal to 68.758. We're not given units, but I'm going to label that as units squared. Okay, sweet. We have one more formula that's given to us, and it's Heron's formula. So this can help us solve for the area of a triangle if we only know the side lengths. And this is pretty big because we have always had to figure out, the base and then figure out the altitude from there. If we're only given all of the side lengths, like within our triangle, we know A, B, and C. Well, it's going to be kind of a drama because in order to figure out what the height is, we're going to have to figure out what this angle is. We'd have to use the law of cosines. That could take a little bit of work. So Heron's formula lets us just be able to plug it in with all of our side lengths. Now, there are a couple different proofs with it. One of them is using the law of cosines, and one of them kind of sneakily uses the Pythagorean theorem. I'm going to link some videos down below if you're interested in the derivation of Heron's formula. Again, not something where I'm going to, expect you to know how to do, mandatory, but it is kind of interesting to see, where these formulas come from. Why didn't we know this in geometry? This would have saved us a lot of times. Well, we know it now, so at least you know it as a sophomore or junior, or freshman. So, Heron's formula basically says that we need to find the semi-perimeter, and the semi-perimeter is the perimeter of our triangle, A plus B plus C, but then divided by 2. So we're finding the semi-perimeter, and then the area of the triangle is equal to the square root of the semi-perimeter times the semi-perimeter minus side length A, times the semi-perimeter minus side length B, minus the semi-perimeter times minus side length C. And that will give us our area. Again, I highly encourage you to watch the derivation because it's kind of cool. So we're going to use this in example 2. We're going to decide whether a triangle can be formed given the side lengths, and if so, we're going to use Heron's formula. So the first part of this is to decide whether a triangle can be formed with the given side lengths. So how do we do that? Well, again, remember, if we're going to have a triangle, it is really important that all of our side lengths, actually match together, right? For instance, let's say I have my side length C, and I have A and B here. Well, if A and B aren't long enough, they're not going to reach our C, or let's say that we have A and we have B, and let's say they're just long enough to barely touch, but when they do so, they are the exact length of side length C. So again, to be able to form a triangle, we need to check to make sure that the 2 smaller side lengths add up to be larger than the biggest. Okay, so we'll check that first just to make sure we can actually form a triangle. I suppose that's important if we're going to find the area of it. So in this case, our 2 smallest side lengths, remember, they're not always given to you in order from smallest to largest. Our smallest side lengths are 9 and 17. So 9 plus 17, we're checking to make sure that's larger than 18. It sure is. So we are going to have a triangle. Okay. So with that, finding the area of it, let's go ahead and find our semi-perimeter. So the semi-perimeter is going to be equal to 9 plus 17 plus 18, and we're going to divide that by 2. Okay, so when I do all of that, 9 plus 17 plus 18, let's see, that is 44. 44 over 2, so that is equal to 22. Okay, so knowing the semi-perimeter, I can now go ahead and plug it into my Heron's formula. So the area is going to be equal to semi-perimeter 22 times 22 minus A, which is 18, times 22 minus B, which is 17, times 22 minus 9. And there we go. Okay, if you have your calculator available to you, I say just plug all of this in and then call it a day, okay? If you don't have your calculator, and let's say, for instance, it's a multiple choice question, let's say, for instance, that, you're trying to find the exact value, you can go ahead and simplify this and see if there's any, perfect squares that you can pull out. So, for instance, what I would maybe look at doing is I'd have 22, let's see, 22 minus 18 is 4, 22 minus 17 is 5. 22 minus 9 is, wow, blanking. 13? Okay, so like for instance, just looking at it, like I know that 4 is a perfect square, so I could pull that out. So that'd be 2 times the square root of 22 times 5 times 13, and I could continue on with here. I could see if there's any way I could rewrite what's inside of the square root, the radicand, to see if there's any perfect squares I can pull out. So if you don't have a calculator, trying to find an exact value, that's how you can do it. If you do have a calculator, just plug this in, don't simplify, and get your answer. So when I do that, our area should be equal to 75.631 units squared. Okay, we have one more example we're looking at. We're checking to see if it's a triangle, and then if so, finding the area. So we have side lengths of 3, 4, and 11. So checking to see if it's a triangle, we're probably going to see that it's not, because if I take my two smallest side lengths, 3 plus 4, those are not greater than 11. So what we have here is this case. Our two of our segments are not long enough to connect and touch, so this will not form a triangle. All right, that's all I have for this video. Just a couple of formulas. Those are on your trig identities sheet. But we're done with Unit 3. Congrats, guys. I'll see you all later.